Hey folks, we're going to start to talk about projectile motion today. So I put up some notes here. You can pause them and write them down. And I'm going to go through them kind of quickly, make this a short video, and then get on to some detailed videos later. So projectile motion is an extension of free fall. To call something as a projectile is to say that it's been launched into the air. And then once that happens, gravity takes over. Obviously, gravity is always there, but the launch produces some initial velocity in a certain direction, and then gravity causes that object to go into free fall and accelerate until it hits something. So that's what a projectile is. That can be something that's like kicked off a surface, it can be dropped, it can be thrown up in the air, it can be launched at an angle. All of those things are projectiles. To describe a projectile, you need two-dimensional kinematics. And so, imagine if you like kick a soccer ball, it moves in an arc, in a parabolic path, which means it's moving both horizontally and vertically at the same time. So we have horizontal and vertical components of motion that occur simultaneously, meaning the object is going to move in the horizontal direction while it is also moving in the vertical direction. The important part of projectile motion from a student standpoint is that those two types of motions happen independently, meaning just because something's moving horizontally doesn't affect its vertical motion, and vice versa. Just because something is moving vertically doesn't mean that that's going to affect its horizontal motion. So our x and y variables don't mix. The only thing that really mixes is time. Because they happen simultaneously, there's only a certain amount of time that that thing's going to spend in the air. So just to kind of show you what I mean, we have horizontal and vertical motion in a projectile. The horizontal motion is defined by an acceleration of 0. So we've talked about how gravity cannot accelerate things horizontally. So forward and backward, left and right, that doesn't happen due to gravity, it happens due to other forces. There's no acceleration. So if I take the position function and look at this horizontal acceleration, things simplify. I have a 0 acceleration, that term leaves, so all horizontal motion can be described by just this one equation. So our final position equals initial position plus initial velocity times time. So you have these 4 variables that are the only 4 variables for horizontal motion that you need to worry about when something's in the air. In the vertical direction, there is an acceleration, and so there's nothing we can cancel. We write an equation for the vertical dimension, and nothing changes. Okay, so y equals y naught plus vy naught times time plus 1/2 ay times t squared. So these two equations are kind of the central equations for projectiles. In the x direction, there's only 4 variables, and things move in constant velocity motion. Constant velocity. In the vertical direction, because of gravity's acceleration, that value of little g, there is changing velocity motion or accelerated motion in the vertical direction. These are the 2 equations we use most often. Because there is an acceleration, we also get access to the rest of the kinematics equations. So if I wanted to chart an object's velocity as it travels through the air, I could use this one. And then if I did not want to incorporate time, I could write this one and describe projectile motion that way. So we will focus mostly on these 2 equations as describing an object's position in 2 dimensions as it flies through the air, but I can also use those for our projectile problems that involve velocity or don't involve time. And so that's that for the intro.